The nature of the Trojan asteroids, this is really weird. There's these asteroids that are in clumps ahead of and behind Jupiter in its orbit. We don't really know that much about them. They're really hard to get to. Comet nuclei, what are they composed of? So you can just go down this list, and you can see some of the key things that NASA wants to fund. All right, that NASA's interested in funding. And the decadal survey missions, and they make recommendations here for specific missions. Small missions they talk about, medium missions, and they actually come right out and say here that in terms of medium-sized missions, we recommend, we, the assembled greatest planetary scientists in the United States, think that the next big New Frontiers mission should either be a comet surface sample return, lunar South Pole sample return, that goes back to the water on the surface, a probe of Saturn, Trojan tour and rendezvous, Trojan asteroids, and the Venus in situ explorer. So they go from, here are the key questions, to here's what we think NASA's next generation of missions ought to be. Okay? That's what these documents do. And then they speak here about the expensive ones, large missions. Okay? The highest priority flagship mission in the next decade for NASA should be, again, we the assembled scientists say this, the Mars Astrobiology Explorer. So they're talking about a follow-on to the rovers that just landed, the $2.5 billion rovers that just landed on Mars. And why do they think this is the case? Why are they thinking this is the key mission?
Because they think we're going to find some really great data on Mars to support possible colonization
Or perhaps ancient life, that Mars was capable of supporting ancient life. So they're already thinking that. So in 10, 15 years, when NASA comes out with some super mission they're going to fly, you'll actually have read it here first. All right? So this is, then their second one. Second highest priority mission they recommend has to do with Europa, which is the most likely place in the solar system for life to exist. Fascinating questions. Europa is covered with ice, but there's a liquid water ocean underneath, and there might be life in that ocean. We don't know. We want to at least get an orbiter around Europa so that we can do some things. It's too expensive to land something on the surface right now, otherwise they'd be recommending this. Okay? So then they have tables here of the different missions, the key science objectives right over here. So if you're looking for ideas for your projects, these are great places to go.
Okay, so I have a few questions. I'm sorry. So
sure, fire away, that's great.
Okay, so what we're looking at right now are these proposals for like future ideas of NASA and whatnot?
What they are, the National Research Council,
okay,
which is an independent body of scientists.
Mm-hmm.
They are saying NASA should look at these things.
Okay. And then going on that, what is NASA doing right now?
NASA right now, we've got the New Horizons mission, which is going to arrive at Pluto in 2015. It's had a 9-year journey, and it's going to have a 36-hour encounter with
window.
Okay, they're going to hear an interesting mission, 36-hour encounter, and they're waiting 9 years for this.
Yeah, and interesting about that, when it launched, Pluto was a planet, and on the way, it wasn't a planet.
Right.
But it's also looking for or other planets now, the Kuiper Belt object, so it's bigger, its mission's bigger.
So Pluto is a big one with New Horizons. We've got the Mars rovers that just landed. Messenger is still orbiting around Mercury, sending back some excellent data. We still got Mars Observer going around Mars, collecting pictures. Let's see, what are the other big ones?
Still have Cassini.
Operating around
Still
Saturn.
operating.
Juno is
on its way to do a inner atmosphere Jupiter.
So guess what? Right now, we've got missions that you don't even know about.
No,
and this is crazy that we never know about these things, isn't it? I mean, whoever talks about the fact that we've got at least 6 or 7 major planetary missions.
The Dawn mission?
Yeah, Dawn to actually go to 2 asteroids. They did the first one. Did they just leave Vesta to go to Ceres? Or leave Ceres to go to Vesta?
They're on their way.
One of the two.
And so, like, with all of these missions, like, I love space exploration, and I think it's an awesome, incredible thing. But, like, what about all of the space junk? Like, what are they doing about that?
That might come out of a question related to human needs.
Okay. Could we do something like that?
Absolutely.
For a report?
Absolutely.
Well, for a research project, not a report, yes.
You can probably figure out a way to do a research project on that. We'll talk about how to narrow these down in a minute.
So does our
No.
It's gotta come from something over here. It could be one of these key questions, if you wanna look at these and help get a question. It could be your personal interest and curiosity. It could be some need that you see that people have, because you think money can be made off it. What about this one right now?
Maybe we ought to move to Earth's.
I'm sorry?
Maybe move to the Earth science ones. Or, I
Yeah,
don't know.
yeah. Earth science is also true. Okay, so this is NASA's planetary science. And I'm just showing you this so you can see how to read this, how to read one of these.
But let me add something in here, though, is that you said you're kind of interested in what's coming out. These missions that are there because of previous missions that have come up, like this thing to do a return from the moon, is because of the L-Cross mission where they crashed a satellite into the moon, and they looked at the rising vapor that came off, the dust, the debris, to say, oh, we did find water on the moon. And so there may be a piece of that L-Cross mission, the database, that could be done to do an analysis of that, or it could be a model of what's the expectation for other sites on the moon that you could follow with, if that's the interest.
Right.
So when you mentioned something about, yeah, I'm really interested in space stuff, but it's also looking at the data that's out there, because as you'll see as we move on, if that's your area, a lot of this data has been collected over the decades and is there available to the public to go in and ask the question and sort through it and figure something out. And that's what drives these missions, because the scientists who do this may answer a question or two, but it's the data they return that scientists that are in this area rely on to go on. So it's big science. Very few scientists at this big science level, which is what we're looking at, are going to have their particular piece, but they're going to get the data from which they say, oh, we found something interesting, like volcano Europa. No, which one? The volcano was found after the fact.
Yeah, on Io.
There, Io.
They turned the spacecraft around and looked back towards Io, and this female graduate student saw a little plume. And that led us to the idea that there are volcanoes on Io. That's the story.
Yeah.
Okay, we don't have a whole lot of time. So this is the executive summary of the Earth Science and Applications from Space. And this shows you what are the key questions that this group of scientists think are important for human needs. And they say here, first one, number one, will there be catastrophic collapse of the world's major ice sheets, Greenland and Antarctica? That's a key question right now, key question. Will droughts, let's talk about timing, will droughts become more widespread in the western U.S., Australia, and sub-Saharan Africa? Well, that's sort of timely with the drought we have going right now. How will this affect wildfires? Right, Colorado, we just had big wildfires out there. How will continuing economic development affect air pollutants? And how will these pollutants be transported? How will coastal and ocean ecosystems respond to changes in physical forcing, meaning climate? Will previously rare diseases become common? There's some virology type questions. Okay, there's such good stuff here. Okay, and that's why I want you to be able to go look at these documents. Look at the executive summary. Read about the questions down in the document. Okay, so there's the key questions from major science organizations. Okay, does everybody see what I want you to be able to do? This is one possible source of ideas for your project. Also, whatever you're interested in, what you think people need, what you can make money off of. So you start off with a big idea, droughts. Let's just pick that one as an example. Droughts. Okay, great earth science question, causes droughts, weather impacts, things like that. Okay.